It's flat.
And it's black.
All right, Jameson, mask on. Malachi, Elijah, mask on. 20 push-ups, 25 cents.
25 push-ups. Do you have an extra?
Push-ups, 25 cents.
Can I
20 push-ups.
Mr. Chartier, can I do 25?
Oh, Jameson's using the screen. Okay. All right, quiet, please. Let's get going. Any questions on the homework before we grade it?
Yes, number 9.
Hey, I cannot work if you guys are talking over me. Somebody count. Quietly. All right, what was the question? What were we going over?
9.
No. Number
9.
9. All right, I'd say this is on the problem. So number 9 says one of two congruent sides of a isosceles triangle. So clearly I need an isosceles triangle. So this side is L, this side is L. That's the two congruent sides. Two congruent sides have a length of 26. So if these two have a side of 26, that means one or both of them added together. Both of them added together. So L plus L equals 26. Right? It says the third side, however, has a, no, that's not what it says. It says one of two congruent sides of an isosceles, one of two congruent, I'm messing this one up. One of two congruent sides. Which one?
Left.
So if this one is 26 and it's a isosceles triangle, then this one is
25. Not 26.
okay. Further, it says that the perimeter is 65. How big is the third side? Well, do we know the third side?
Do we know all the sides?
Oh my God.
Hey, Elijah, go outside. Wait for me. All right, back up here. Isosceles triangle, that means two sides are the same. It says one of them is 26, therefore the other one is 26. It says nothing about the third side, that is your x. It does say the P perimeter is equal to 65. This is exactly what we did in class. Therefore, I know that this one, Gavin,
Yes, that's
complete my sentence. So therefore, I know that this one,
It's gonna be 50.
therefore, I know that this one,
26
finish the sentence.
is congruent to 26, and then we have to add the 26s, and then whenever we add the 26s, we subtract the 26s.
So let's just think about the equation before we do any math. What's the equation?
26 plus 26 equals plus x.
26 plus 26 equals x
No, plus x.
equals,
65.
that's the equation. So we get two 26s. I guess you could do that in your head, or you could write that out. Either one's fine. So if you want to do the long way, 26 plus 26 plus x equals 90 or 65. Some of you realized immediately that 26 and 26 is, so this is really 52 plus x equals 65. That's your equation. Solve that and you're done.
Couldn't you just do 26 times 2?
You could, and that's what I would have done. Right. All right. Any other questions on this homework? Yes.
2.
All right. Number 2.
Oh no.
Number 2. Carrie's car went 224 kilometers on 28 liters of gas. How many kilometers per liter? How many kilometers per liter is this? Okay, the picture is kind of weak, but here's a box and it says how many kilometers per liter. So this is a 1 liter box. Like inside this box, I can put 1 liter of gas, 1 L. I don't know how many kilometers, so there's my X. But I do know how many liters of gas I used. Whose question was this? How many liters of gas did you use? Help them out.
224.
No, that's kilometers.
Oh.
How many liters?
28.
So if this box is 1 liters and I gotta get to 28, how many boxes do I need?
You need 28 boxes.
I need 28 of those 1 liter boxes. And each one goes how far? Each box goes how far? I don't know. But I do know how far I went. And that's what you gotta solve. There will be 4 of these on the test on Mondays. Monday? Yeah, Monday. 4 word problems on the test on Monday. You need to know how to solve these. I would recommend we get the practice test tomorrow. If the word problems are your thing that give you the issue, is that you write those problems that I show you on the practice test down, and that's on your resource card, and that's what you bring in. All right. Who's the smartest kid in the class?
Wow.
There.
Why?
Wait,
You know the problems. Pull out the answers, grade it, and when that's done, collect any things. I need to take care of this.
No. Why? You in trouble?
go ahead, go.
No. Okay.
1 through 9.
Dude, they're probably okay.
Number 1, 9 n equals 100. 1,170.
Yeah.
And then I don't know what answer you just got.
A little bit louder so everyone can hear.
Okay.
Are you really that lost?
I know what to do.
It's in red. Just call out the answers.
Number 2, 28 n equals 224. That's right, Homer.
Oh boy, did I put the wrong person in charge? Thank you,
No,
Dave,
it's
for
right
your,
the one. It's right one.
thank you for your attempt.
No, it's the right one.
All right, here we go. What did we leave off on?
2.
Number 2, she was doing okay. She's just a little confused. All right, number 2 is 20. Now, you could choose any variable that you want. Number 2 is 28. They choose n, but I chose x every time. 28n equals 224. Hey, we just did that one on the board. Number 3, 6n equals 90. Number 4, n minus 525 equals 325. Number 5, 144 minus n equals 116. Yeah. Good. I mean, you're one step ahead.
I was solving it too. That's why.
Well, that's fine. I mean, we still, the instructions say choose a variable and write the equation for each problem.
I did read the equation. I was supposed to solve it.
Yeah, that's what I did too. I solved it.
Then you didn't read the instructions, did you? Number
I don't
6,
read the instructions.
n plus 350 equals 1,508. That'll get you into big problems in math if you don't read the instructions.
Yeah, I realized I've learned that lesson, history, multiple times.
Okay.
What's number 6?
I will put a question on the test just for you, Gavin, to see if you're paying attention to the question. Okay?
Gavin.
All right. Number 7, we will call it the Gavin question. Number 7. Woe unto you that missed the Gavin question on the next test. Number 7, 29 plus 43 plus n equals 100. Now, I would accept, some of you would look at that like, well, I already added the 29, 43, and I put 72. So if you put 72 plus n equals 100, that's fine. Number 8, 4n equals 60. We did the last one on the board. Either 26 plus 26 plus n equals 65, or what, 52 plus n equals 65. Either one's fine. And that was it. All right. What? Pass out. Okay, hey, did anyone notice how many steps were in each one of those equations last night for
A
homework?
lot of them.
Steps. There were only one-step equations. So yesterday was one-step equation problems. Today will be
2,
two-step equation problems.
or maybe even
No, it won't be fun. Not until algebra 1. All right, test on Monday. We will review tomorrow. Here is your homework. Please copy it down. Guess why I want you to do the odds?
Because they're hard and they're gonna be a pain in our butt.
No. Who's the smart kids in class? Why would I give you the odds and not the evens?
Because we won't go to.
Because I want you to check the answer in the back of the book. I know, historically speaking, that word problems are the thing that give people issues. So I want you to have confidence that you can do these problems. Done.
No.
The answers are in the back of the book? Yeah. I knew.
What month is this?
January.
No.
So clearly we know now who hasn't been paying attention. And take your jacket off. All right. Yes, the answers have been in the back of the book since the day that I gave you the book. We went over the book and I told you that the answers are in the back of the book. Math books from now on will always have the answers in the back of the book. Every single math book that you get in high school and college, they give you the answers. Not to all of them, but generally speaking to the odds. In college, I always had every single answer to any problem I ever did when I took a math course. Why? Well, because their grade is only on a test, and then two, it's important to be able to get some feedback when you're doing a problem, especially a hard one, that you're doing it correct. Hey, I got 14. Hey, look, the answer's 14. Yes, I know what I'm doing. If you have a problem and all you're doing, well, I think this is what I'm supposed to do, then you just did hours worth of homework and you got nothing out of it because you did them all wrong. Do the first one, you get it wrong, you check the back of the book, oh wait, it's this. Now, that said, at least until we get to like high school, I generally only give the evens unless it's a very challenging problem. So I'm not going to say I really think this is hugely challenging tonight. It's not. But I also want you to have a chance so that we get to class. I didn't get any of this stuff, right? Well, I want you to try it. Check the back of the book. Oh, now I see why that's done that way. That's kind of what's supposed to occur here. So why don't I always give you the odds? Well, unfortunately, you're in 7th grade. So the power of knowing that all the answers in the back of the book will overwhelm some of you. And I will literally have kids say, well, you give me the answers in the back of the book. I'm just going to write them down. So generally speaking, I don't assign the odds. However, you can always do an odd problem or two on your own to assure yourself that you're doing it correctly. I give you number 22, and you look at 22 and you're like, I don't know how to do that. Look at number 21 or maybe 23. Maybe it's just like that problem. You can take a guess, check the back of your book, and confirm to yourself that, oh, yeah, I am doing it right. Okay? All right, here we go. More word problems. Right? More word problems, generally our reaction is
Hey, it's
Right.
like me.
so don't be that kid.
Yes, I will be that kid.
All right, so we are going to, as we've done in the past, we are simply going to do these word problems together. Now, someone open your book to the homework and tell me what the instructions say.
Why?
Does it say solve it or does it say write the equation?
Solve each problem.
Solve each problem. So different from last night. Last night it was just write the equation. Tonight it's write the equation and solve it. Okay. So yesterday in class we had plenty of people that because it was a one-step problem, they were like, well, I can figure this out because it's only one step. Well, now it's going to be a two-step problem. So generally speaking, most people will not be able to do this in their head. All right, so we're going to do 5 of these together. I chose 5 that are so similar to the homework ones that you can use the sheet in front of you as a guide for your homework. So here we go. Now, it kind of has the same flavor as yesterday, so you'll see some commonality between yesterday's class and today's class. It starts off the congruent angles of an isosceles triangle. So what should I immediately draw? A triangle. So I'm going to draw an isosceles triangle. It says the congruent angles. So an isosceles triangle has how many congruent angles? 2. And they are, I don't know if you remember this, they are opposite the two congruent sides. So if these are the two congruent sides, then these are the two congruent angles. Let's continue reading. Each have a measure of 65. So if this angle is 65, then, so we could label that, okay? Now, we have to think back upon our knowledge of triangles.
Knowledge.
All three angles in any triangle add up to
180.
180. So could I figure out the third one?
Yeah.
Find the measure of the third angle. So what would I have to do to these two?
Add them together.
And then,
Subtract them from 180.
so these two plus the third, we don't know what the third, so we're going to assign the third the variable
C.
or x or whatever you want. So the equation, because it says set up an equation and solve it, would be, what would the equation be?
65 times 2 plus x equals 180.
Okay, and some people might write it as 65 plus 65, but that's fine what you said as well too. Could you solve this equation? Okay, this one's pretty easy. 65 and 65 is 130. And then we would need to
Subtract 130.
both sides, therefore x is equal to. And you have one easy one. This was not a two-step, this is technically a one-step because they expected you to already know that 65 and 65 is 130. So this is really just a one-step equation. Okay, I like how you've written everything that I put on the board on your paper after I stated the fact that these are exactly like what are in the homework. So for those of you that did, Jaden is one of them, right? Congratulations, you're doing what you're supposed to do. Well, I did it, right? But don't sit there like a bump on a log and watch me do math on the board. You are part of this process. All right, are we okay with example number 1? Example number 2. What the heck is an evergreen tree?
It's
Big tweet.
like
What's an evergreen tree?
A green tree.
Okay, so most trees are green. So what makes it an evergreen tree?
It's
Green
forever.
Until it dies, right? But during the winter, it doesn't drop its leaves, right?
One tough tree.
Pine trees are an example of an evergreen tree, right? An evergreen tree in Sam's yard is 178 feet or 170 inches tall, not very tall. Okay,
78 inches tall.
what did I say?
170.
See, I was already making it bigger. 78 inches tall. If it grows 6 inches each year, how many years will it take to grow to 108 inches? Let's draw a picture. So most people would immediately try to draw a tree. Guess what I'm going to draw?
A tree.
I'm going to draw a box, right? So how tall is my box?
78 inches.
Okay, well, there's my start. At the start, my tree, it looks like a box, not a tree. My tree is how tall? So from the bottom to the top, that's what she was trying to say, is 78 inches. How tall does it grow each year?
6 inches.
6 inches. Now, this is not it's not to scale or anything like that, but the next year, in 1 year, it grows 1 inch. I'm sorry, 6 inches. And then the next year it grows 6 inches. So the question is, how many of those will it take until the whole thing is, here's your first two-stepper. Okay? Could you do this picture all by yourself?
Yeah.
Right? So here is what you must do. Somehow that picture needs to get translated into an equation. How tall is it at the start?
78.
So at the end, it's going to be how tall?
108.
Here is your equation. This picture is the equation. All of you should be, now granted, I mean, this is not 108 inches yet. I've left off a whole bunch of boxes because I don't know how many boxes, right? So guess what, how many boxes I'm going to have? If I don't know how many, and each box represents how many inches?
6.
So 6x would be how many boxes times 6 that needs to grow until it adds up to 108. But wait a minute, it was 78 inches at the start. So this number never changed. This is the equation right here.
It's 6x plus 78 equals 100.
That is the equation. It starts off with the fact that 78 doesn't ever change. What does change is how many of these little tiny boxes. How many do I need? I don't know. I need X number of boxes, but each box represents 6 inches of growth. All together at the end, we're supposed to have 108 inches. So here is the equation that you need to solve.
Homework, that's what you have to do, right?
Oh no, it says solve. Right? Am I correct? Is that what it says?
Yes.
It says write an equation and then solve it.
Yes.
Hey, I wrote the equation. Let's solve it. Step 1.
You divide 6 from both
Absolutely
sides.
not. When you have a 2-step equation, I say, except for next year when there's one exception,
Oh,
I
you
recommend
subtract
getting rid of
78.
the addition subtraction first.
Yeah, you subtract 78.
So I'm going to get rid of the 78 first. So I subtract 78 from both sides. I'll do that math for you very quickly. Last step,
You divide both sides from 6.
by 6.
X equals 5.
And therefore X equals 5. Now what does that 5 represent? 5 inches?
Years.
It will take 5 years for our tree to grow to 108 inches.
That's
Well, I
like
did it wrong then. 'cause I
I would
got
be an adult by the time you grow.
split.
That's like 6
If you have not ever noticed, trees grow slowly.
Oh, I didn't.
My baby doesn't
All right.
slowly.
All right, stay with me. So there are 2 examples. You should have both examples on your paper. Now, does your picture have to look like my picture? No, some people will actually draw trees. But generally speaking, this is how the picture should look. Okay? I said we're doing 5. We've already done 2. We only have 3 left. 3 left. Is the attention where it needs to be? All right, here we go. Oh, we love triangles. Now, you're going to see lots of triangles. Does anybody know what the reason why?
Because we as a human society are obsessed and in love with triangles.
Why?
Because we find them fascinating.
No,
They're just strong.
everything can be made with triangles. Malachi, give me any shape you want.
That was easy.
What happens if I put a dot in the middle and I connect this dot to the corners? Guess what I get?
Triangle.
I got a shape that's made up of nothing but triangles.
Hexagon then.
You still box. Circle then. You're wasting your homework. It'll be 4 times.
Put a dot in the middle, it'll be 6 because it's a 6 sides.
Oh, yeah.
And you get 6 triangles.
I was circle. Fractal.
Oh wait, I shouldn't have done that.
Circle is so easy. What?
No,
What about a
because like,
triangle?
Pizza.
I was thinking that it would have a straight
It
line, but
has
it's-
triangles.
Wait.
Rectangle.
A rectangle. A
Cone,
rectangle
a
is the same
cone,
as a
you gotta do
square.
a cone. A triangle.
That's not triangle. Jaden.
Triangle doesn't
That's
count.
a cone.
Oh, wait,
Wait,
I thought it
that
was a
that can't do it.
Well, so it turns out if you've ever played video games and you've ever paid attention to them,
Polygons.
Nope. I
they're
don't.
all made with, well, they say the word polygons, but guess what they really mean?
Triangle.
Triangles.
Okay,
Now, you can't zoom in on the picture, but if you could, or you could see on the how they actually draw the pictures, it's just made up of triangles. They will throw some weird polygons as well too, but it's mostly triangles. And any polygon, you can simply put a dot in the middle and you can make it with triangles.
Oh, any polygon. So fractal would work.
Any shape can be separated. By the way, last time I played video games, there were human beings, and we are not polygons. However, the surfaces of any shape can be broken up into little tiny triangles. As soon as you have them small enough when you're zoomed out, then your eyeball can't see that detail, and it looks like a smooth or curved surface. That's how they do it.
You want no won't do it.
All right. I just told you why an oval will work, right? All right, what's your question? Sure. So it says one triangle, once again, that's the explanation why there's triangles. One triangle, one angle of a triangle is 90 degrees. So clearly I need to draw a
90 degrees.
right triangle because one of the angles is 90 degrees, right? Obviously the angle that's 90 is 90, or the right angle is 90. It says the other two are congruent. That means this angle and this angle are the same. Do we know how much this one is?
No.
So therefore this one has X, and if it's the same as the other one, then they're both X.
290.
And we do what we did from box 1. What's the equation?
90 plus.
No, what's the equation? Start with X.
X plus 1 plus x plus 90 equals 180.
Perfect.
Or you could have done 90 plus 2x.
Now, if you're ahead of the game, you see where this is going. You know that x plus x is.
2x.
Now you could have. That's what Vay was trying to say from the start. I just didn't. Some kids aren't there yet. All right. Can you solve that now?
Yes.
First step.
You subtract 90 from both sides, and then you would get 2x equals 90.
Therefore, x is equal to. No, let's stay with the class.
45.
Okay. Because 90 divided by 2, both sides is 45. Now, we were solving for an angle measurement, so technically we put a little degree symbol next to it. There you go. Find the measure of one of the congruent angles. We've answered the question.
And then you divide 45 divided by 2.
No. Because when you're solving for x, we said x was one of the angles, not both.
Well, it's the same. So
It is the same, so they're both 45, correct. So isosceles triangle. Okay, easy ones are done. The last two are your challenging ones. Okay, if there's an issue, it'll be on the last two. So we're going to spend some time, the last, I don't know, 20 minutes of class on just two problems. Okay, here we go. Jameson, you're drooling. All right. 3/4 of all the books in the school library are nonfiction. What the heck is nonfiction?
Not real.
What do you got, Jameson?
Real.
Is it real or not real?
Real.
Malachi?
How did Jameson
So-
not know whenever he reads so many books?
Yeah, but he only reads fiction. That's the only thing I've ever seen in front of him. Malachi, give an example of a nonfiction book that you've read this year.
I haven't read a book this year.
Okay, I'm not asking you.
Call the Wild.
Call the Wild is fiction.
Oh, I know.
It's a story made up by someone. Give me a nonfiction book that you've read this year. And maybe you haven't read the whole book, but portions of it.
Science.
Okay, well, they're throwing out science book. Is your science book fiction or nonfiction?
Fiction.
Non-fiction.
It's nonfiction book. Hey, let's not have a repeat of yesterday. It's a nonfiction book, right? Some other examples would be, I don't know if you've read,
What's an
you read a book on astrophysicists, right?
Winston Churchill.
You read a biography. That was kind of what I was thinking from the very start. A biography is written the real life of a human being, right? Remember, biography can be written by anyone. If it's written by that person, it's called a autobiography. What?
What's the tropical?
We're not there yet. We're still on this one. Okay. All right. So 3/4 of all the books in the school library are nonfiction. That would leave
The rest of the book.
as being
1/4.
if 3/4 are nonfiction, that would leave as fiction, right? All right. It says there are 360 nonfiction books. How many are in this? How in the world could I figure this out if I don't know how many books are in the library? All the other questions before, like the triangle one we did before, it said in total, right? Either we knew it was 180, it was part of the problem, or it specifically said in total you have, $1,150, something like that. This one, it does. That's what the question is. How many books are in the library? Well, I don't know because you haven't told me how many books there are of both fiction and nonfiction. You've only told me one of them. It seems like this is an impossible problem. So one way that will always help you is to draw a picture. Maybe it'll help you wrap your heads around it. So guess what I'm going to draw for a library? A box, always. All right. So here is my library. Inside of my library, I have two types of books. What types of books?
Fiction and non-fiction.
Do we know how much we have of either one of them?
Yes.
Which one?
We know how much nonfiction we have. We have 3/4 of nonfiction and overall.
No, how many books do we have of either one?
360 of nonfiction.
We have 360 nonfiction books. Once again, if the questions that would have been asked before would be something like, there are 1,000 books in the library, 360 are nonfiction, how many fiction? But notice the change here. This is 360 nonfiction books. How many are in the library? Well, I need to know how many fiction books. And then add the two together and it doesn't tell me that. So that method is gone. We can't use that.
You can do 360 plus 1/4.
1/4 of what? See what I mean? If I told you there were 1,000 books in the library, 1/4 of that would be 250. We could do that calculation. It would be simple. But what I don't know is, once again, and I also don't know,
How many books are in a library?
so I have two variables potentially. So when you have the possibility, next year you will have two, but this year will only be one. When next year you're going to have an X and a Y or a Z or whatever. But this year they're only going to have one variable X. So the question is, does fiction get the X or does the library get the X? To answer that question, we look at the question itself and we say, well, what is it asking?
It's asking how many books are in the library.
So does the fiction get the X or does the library get the X?
The library. gets
The
the
library gets the X.
Library gets.
Okay. There is my picture of what's going on. It turns out I don't need to worry about the fiction. Because I'm trying to figure out how many are in the library, and it tells me the relationship between nonfiction and the library. What's that relationship? Tells me that there's three. Malachi, is that what you're going to say? There's 3/4 of the library is sitting right here in nonfiction. 3/4. 3/4 of what?
What?
How many books?
300.
Oh no, the total amount of books which we have labeled as, so 3/4 of, which is what in our picture? So 3/4 of, say it, what I just said, 3/4 of X is 360. I don't know, let's set up the equation first. 3/4 of what
X
is equal to,
360.
there is your equation.
Yay.
And I'm just going to say, after years of doing this problem right here causes big, big, big problems. Girls,
Huh?
not you.
Laser.
Let's hold off the restroom. Let's get these done. All right, I'll let you go before class is over. 3/4 of X is equal to 360. 3/4 of X. Now, how did I do all this? Step number one. Now, we're not going to get to the equation yet. How did I do this? Well, I drew a picture. The issue here is, and where you'll run is that you're going to have two different things that you don't know what. Read the problem, the thing that they give you or that they're asking you to find, right? The unknown there, that's what gets the variable. Next year, fiction books will get a Y, but not this year. Next year, we'll be able to figure out through an equation how to solve that, but not this year. All right, now let's solve this puppy. All right. Where's X?
To the right.
Left side.
Left.
Left side.
Left.
What's attached to it?
3/4.
How is it attached?
Division.
It's not attached by division.
Oh, multiplication.
How do we get rid of multiplication?
Division.
So what are we going to multiply both sides by?
4/3.
The reciprocal, right? Because remember, and I said multiplication, I meant divide. We're going to divide both sides by 3/4, but dividing by 3/4 is a copy dot flip. So a division with a fraction is the same as multiplying by the reciprocal. So we are going to multiply both sides by 4/3. Do you remember doing that? Whenever there was a fraction attached to the variable, you multiply by the fraction flipped. That's the copy dot flip. You're copying the 3/4. You're flipping the 3/4 into 4/3. But you got to do it to both sides. Left side, everything cancels, and on the right side, anything cross reduce.
Yeah.
What?
360 and 3.
Okay, so 3 goes into 3.
1.
3 goes into 360. Here said 120. He is correct. Last step.
Multiply.
12 times 4.
It's 48.
And so 120 times 4 would be,
480.
and you're done. There are how many books in the library?
480.
Now, if they really wanted to make your life horrible, guess what the question would actually ask?
How many books are fiction?
That's next year.
That would be horrible.
But it would be easy once we figure out how many books are in the library. Then you would just subtract. So how many books are nonfiction?
120.
I'm sorry, how many books are fiction? 120. Be ready for that next year, not this year. Last one. I said we were gonna take 10 minutes per one. That took us 10 minutes to get through that one problem. Expect tonight, it's gonna take you some time to get through these problems. A department store. I don't know if we're gonna have department stores much longer. A department store received 5 cartons of shirts. Does everyone know what a carton is?
What's a department store?
Exactly. A department store received 5 cartons of shirts. Sears,
Oh.
Kmart, Walmart, all those.
Oh, Walmart's not going anywhere.
Yeah. A department store received Target's a department store. The store has departments inside that sell individual things. So it used to be back in, I don't know, even before I was born, you didn't have department stores. You had a store that sold nails. You had a
Just
store that
nails?
sold tires. You had a store that sold socks.
Well,
So some smart person, it's started probably the 20th century. Some smart person said, well, how about if we have a store that sells everything? We'll have a department that sells car parts. We'll have a department that sells clothes. We'll have a department that's that's why they're called department stores. But they're on their way out because everybody buys things online. A department store receives 5 cartons of shirts. How many shirts are in each carton?
5 currents. I don't know.
I don't know either.
X.
There you go. A department store received 5 cartons of shirts. 1 week later, 25 shirts have been sold, 95 are left. How many shirts are in each box? Once again, it seems like an impossible problem. How in the world do I know if you don't tell me how many are in each box?
We do.
It's unknown. So once again, our old trusty technique of drawing a picture works. At the start of this problem, what do we have? At the start, before anything's sold, before anything's done, what do we got? We got a department store, and what's in this department store?
5 cartons of shirts.
We have 5 cartons of shirts. So guess what I'm going to draw?
5 cartons of shirts.
I'm going to draw 5 cartons of shirts.
That's a lot.
Elijah said, how many shirts are in each carton?
X.
He said, I don't know. So therefore, it's X. There are X shirts in each carton. Therefore, altogether, guess what I have? Just right here from this one picture.
5X.
I got 5X. Do you see that?
Yeah, I saw
5 times X. 5 is the number of cartons. X is the number of each shirt. So how many shirts do you have? I don't know. 5X. Okay. What happens next in our problem?
that. And then 1 week later, 25 shirts have been sold.
So mathematically, what would I write?
Minus 25.
Everybody understand why we're writing minus 25?
And then 95.
Hold. Make sure everybody agrees. Good?
Yes.
And then 95 shirts are left.
So what do you want me to write?
5X minus 25 equals 95.
So at the end, you have 95 shirts. So the equation is from this picture. We said that the picture of the boxes is, what do we get from here?
5X.
5X, because there's in each box, there's X shirts. So 5 times, how many shirts? If there's 1 shirt in each box, 5 times 1, there's 5 shirts. But if there's 2 shirts in each box, it's 5 times 2. We don't know how many shirts are in each box, so it's 5 times X. And then read what's left.
How many shirts?
No, in our picture. So this was 5X.
And then there's 95.
5X, just read what it says. 5X,
Minus 25 equals 95.
that's my equation.
Yay.
When you get comfortable with doing this, it's no big deal. When you're not comfortable with drawing a picture, you stare at a problem for, well, you guys will do it for 1 minute. And then you'll say, Mr. C, I don't know what I'm doing. And I'll say, where's your picture? You're like, I don't know. I didn't draw a picture. If you draw the picture, read it carefully, try to draw a picture. My claim is that eventually you will get to where you can do this without any of my help. I don't know if you caught the dig there I was making. I said, if you look at it for 1 minute, some of these you got to look at them far longer than 1 minute. Other class, I had a person not to be named. I have them for student advisement, and they're sitting there, and I said she. The person goes, I don't know how to do number 1. So we did number 1 together. I start to walk away. I've gotten she sits right there where Kira's sitting. And I get to my desk, and all of a sudden, Mr. C, I don't get number 2. So I help her with number 2.
I'll get number
And
three.
then I start walking away. I don't even get to my destination. I don't know how to do number 3. And literally, I was like, okay, I'm done. I'm done. I'm not helping you any longer. Right? You're not even trying. Now, great. I don't want you to sit there for hours, right? But I do want you to give it a shot, right? Don't just assume immediately, like, I don't know what I'm doing. Give it a shot. There's a reason why people don't like word problems,
You're a
Because
pain.
of word problems.
because they're intentionally vague, right? And the real reason is this. Hey, what are all these things up here that I'm circling?
Numbers.
They're words. There's a couple numbers up there. What's this?
A problem.
It's just an equation. We are very happy and comfortable with equations because we know there's a nice, simple process to solve it. What we're not comfortable with is interchanging these 2 languages, the language of English and the language of math. Right? Unfortunately for the human race, guess what?
What?
You don't need math.
You'd be dead without math.
Wow.
You wear glasses, right?
No,
How did they figure out how to get those glasses on your face?
These are glasses.
It's a math problem. Do you know what happened? Oh, let's say 10,000 years ago to people who needed glasses?
You killed them.
No.
No.
The saber-toothed tiger ate your butt
That's what I
because you couldn't see the saber-toothed tiger, or the snake bit you and you died. I'm slightly exaggerating, but not much. Guess what happened to people who couldn't see?
They died.
They died for many reasons. One, oh, there's a cliff. Wow! They couldn't see the cliff.
I'm not that blind.
I could see shapes.
There weren't cars, so they didn't get hit by cars.
That's it.
But the elephant stepped on them and killed them, that's for sure, because they couldn't see the elephant.
I
That's
can-
probably an exaggeration.
I can
I
wait
see
for
a
the
giant
department store to
elephant
receive
with
cartons
a
of
hood
shirts.
I can't see
1 week
anything.
later,
I
25
mean, I can
shirts were
see
sold.
it's just.
If I took off your glasses, Jameson, and threw something at you, could you catch it?
Yeah.
My dad done it like almost time. My glasses were broken out.
It's a Chartier. Here you go.
Sit.
Aw, I wanna use
All right. So the issue with word problems is, one, it's a different language. It's English.
No one
Right.
likes English.
The second issue is that, well, you guys are 7th graders, and many of you are not willing to do anything more than 5 or 6 seconds. And then you're like, okay, I don't know what the answer is. I give up. So 2 things make this better. One, acknowledging that we all have issues with perseverance. Right? That's one of our core virtues here, perseverance. We all have, myself included, like, I don't know, I'll give up after, I'll do it more than 5 minutes, but I'll give up as well too. So don't give up. And then the second issue is, it's that darn issue of, well, you got to be able to read. And sometimes math is never vague. It's straightforward. Oh, it's 2-step equation. I know exactly what to do. But when it's in English, sometimes it can be vague. So how do we fix that issue? And I'm going to claim it's by drawing a picture. I'm not going to claim that every single time that you can solve it with a picture, but most of the time, I've yet to see a word problem where a picture doesn't help. Okay, you just need to invest the time, and the more of these you do, the more comfortable you get. And I kind of go away from my point. My main point was, why is this important? Is because every problem that you will encounter in your life that involves math will be I'm not talking about real life, not sitting in the classroom life. Hey, it's time to buy my first house. At some point, you're going to be there. Well, how do you buy your first house?
math.
You have to figure out the math. Can I afford the house?
No.
Right? How does that done? That's done with you sitting down with a piece of paper, right? Website, app, whatever you use, and you got to do some math with it. How much do I make? How much are my bills? All that jazz. It's a math problem. That's an easy math problem. Figure out how much you can afford. Harder math problem is, where should I invest my money? That sort of thing. Harder math problem is, maybe some of you will be a business owner. Where should I place the profits of my business? Should I buy more new things? Should I have more employees? How much should I pay this person? They're all math problems. Every one of them is a math problem. For those of you that hate math, and some of you certainly do, you're not going to escape it. It's part of your life. You have to do math at some level. Some people do high-level math. Some people do low-level math. Every human being does math. Most species do math. My dog does math. I've told you that before, right?
No?
Do you know what type of math I do?
My cat goes to sleep, but my dog does math, right? I told you this story. If I take cheese and take a string cheese and break it up into little tiny pieces and put a tiny pile and a big pile, and I let my dog go, guess what my dog does?
What's the small pile?
Goes to the big pile. That's math.
Small one.
Now, granted, that's you're saying that's not math?
That's just
How does the dog know?
By looking at them. See?
That's math. That's a greater than, less than. That is literally that right there. That's a math problem that my dog does, and your
My
dog
dog.
can do. Like I said, cats typically fall asleep, but dogs can do math.
My dog.
Not very high level math.
My dog ain't an adult.
I'm gonna show my dog it out.
All right. We have not solved this problem. Let's solve it. First step. First step.
You add.
Other than Vegas, someone else. What do you got, Kira? Both sides. 95 is 1 less than 100. What's 100 plus 25? And what's 5 less than 125?
120.
95 is not 100, it's 5 less. So I said, hey, this is how many math people do math easy. You just make nice friendly numbers. What's 100 plus 25? But it's not 100, it's 95, it's 5 less. So what's 5 less than 125?
And then we divide both sides by 5.
Divide both sides by 5,
24.
and we get finally, and what does that 24 mean?
That means 24 shirts are in each carton.
Now we could make this problem harder by saying what? Look at the board. We can make this problem harder by saying what?
How
What's the
many
size of
shirts
the
are left?
We know 95.
No, we don't know how many shirts are left.
Hey, how many shirts were bought at the start?
Easy.
25.
Clearly not. How many shirts were bought by the department store?
120.
524.
Well, how many are in each carton? So how many shirts did they buy?
You will use times 24 times 5.
So next year they make these problems harder. They add an extra step. Meaning like you would have to figure out how many are in each box. Jasmine, are you paying any attention? How many are in each box? And then the question won't say how many are in each box. It'll say how many total shirts were bought by the company.
Probably.
Which you would still have to solve it the same way. You first have to figure out how much are in each box, and then apply that to how many boxes were bought.
Then I would times 24 by 5, which is 100.
And then the year after that, they'll make it even more complicated. They'll say the company buys the shirts for $10, and they sell it for each shirt for $22. Right? How much profit did the company make?
Too much.
Well, you'd have to first figure out how many shirts they bought.
Yeah.
Times it by 10, that's how much they spend.
1,200.
If they sell all the shirts, it would be that same number times 22 and then subtract the 2. I can take this same 7th grade, in my mind, this isn't too challenging of a problem, but your mind probably is, and make it more complicated just by asking something else about the same problem. Be ready for it next year because that's what they'll do. Any questions on anything we did?
Now,
Gavin,
A.
what's a
Well, give me a minute.
hexagon is what I thought you said.
Oh, it's,
Regular hexagon?
trapezoid.
Trapezoid. A trapezoid, you've already forgotten quadrilaterals, is a 4-sided figure where 2 sides are no parallel to each other. So there is a trapezoid. Yes.
A square is
What's the perimeter or something?
Perimeter is the distance around an object. Add up all the sides.
Then what's the?
Perimeter of a circle is circumference, 2 pi r.
But wouldn't the perimeter of a triangle be 180?
No, that's all the angles. Perimeter of a triangle is all 3 sides added up. Yes. Yes. Did somebody else ask, or was that you? All right, go. All right, that is it. Pack it up. All right, any e-learners online right now? There are none. E-learners, if you have any questions, send me a chat or an email. I will catch you guys tomorrow.